morning, everyone. So the today topic is design and analysis of algorithm. And in this algorithm subject, we will discuss divide and conquer. My name is Vishal Chaudhary, and I am from AKGEC College, Department of CSC. So this is the content. First, we will discuss what is an algorithm. Next, characteristics of an algorithm. Next, analysis of algorithm. Next, the first divide and conquer technique which comes under the algorithm, that is divide and conquer. Next, we will analyze divide and conquer like the time complexity and all. Then we will discuss examples of divide and conquer. Okay, next, in the divide and conquer, first example is quick short. I'll discuss quick short. Then I'll discuss quick short performance, like basis on best case, worst case, average case. Then we'll conclude the quick short. Now, the first is what is an algorithm? Basically, algorithm kya hai? What is an algorithm? It is a step-by-step process to solve a particular problem. Let's say we have a problem of making a tea. So problem is making a tea, and the solution is step-by-step process. Like first we have to take a pen, then we have to take a 1 cup of water, then we have to add 1 tablespoon tea, then 1 tablespoon sugar, then 1 cup or a half cup milk, then we will have to boil at least for 10 minutes, right? So the problem was making a tea, and the solution was the step-by-step process to solve a particular problem, right? Same cheese. To solve a particular problem, we have to show we have a step-by-step process to solve a particular problem, right? Now, algorithm should have at least these number of characteristics. Like it should have a termination condition. First, we will discuss the input. If an algorithm doesn't have an input, so it will perform on what basis? Like it should have at least 0 or more input. First point is characteristics of an algorithm. Next, output. If an algorithm is not giving any output, what does that mean? It is giving nothing. So there is no point of designing algorithm which doesn't give any output. So algorithm should have at least 1 or more output. Next point is finiteness. Right? Algorithm must complete after finite number of steps. That means there should have at least one termination condition. If the algorithm does not have any termination condition, it will go into the stack overflow. The term is stack overflow. So algorithm should have at least one termination condition, right? Next is definedness. That means all the steps in the algorithm, like what I've said in the algorithm part, step-by-step process to solve a particular problem. In the algorithm subject or in the algorithm of any particular problem, if any number of step is repeated, then what does it mean? It is ambiguous. So there should be not that point. So an ambiguity should be there. Like no such step should be there jo repeat ho rahe ho. Repetition is not allowed in this algorithm. Next is effectiveness. The step of an algorithm must be effective, can be done successfully. Like every step should be useful in the algorithm. There should not be sub-step, like suppose we have a step like a of I equals to some number, but we are not using this particular place, right? I have assigned the value of x in the 8th array A in the ith position, but I am not using this. So this should not be the case, right? All the steps in the algorithm should be effective. Now, analysis of algorithm. Now we can analyze algorithm in 2 steps, or on basis of two things. Like first is time and space. Time is basically further divided into 2 parts: CPU time plus compiler time. Compiler time. CPU time is what? Which processor we are using? Generally we have i3, i5, i7. No, see, the CPU time is which CPU we are using, like which processor we are using. Generally we have i3, i5, i7. Next, what is the compile time? The time which the program is using to compile the program is called a compiler time. Okay. So these are the first analysis of algorithm, time complexity. Next is space. Space complexity is nothing but how many stack size is using the algorithm. Suppose we have an algorithm n, which input n, and it's further divided into 2 parts, n by 2 n by 2. Suppose करिए, suppose. Next further, n by 2 square, n by 2 square, so if I observe here, what we are doing, we are dividing a particular problem into two parts by half, always by half, right? So here we will go up to log base 2 n levels. So this would be the stack size for this particular problem. Clear? Next, algorithm design techniques. As I have said, what is an algorithm? It is a step-by-step process to solve a particular problem. Now we are solving problem. Okay. So problem solving should have some techniques. Like in the algorithm, we have basically 6 techniques. First one is divide and conquer, that I will discuss later. Next is brute force transformation. Now see, what is divide and conquer? Divide and conquer is nothing but breaking the major problem or the main problem into sub problems. To solve that particular sub problem, then we will combine a sub problem and we will get the answer. Next, brute force. What is brute force? Brute force will try all the possibilities. It will try all the possibilities. Like suppose we have here, see, this is the source, this is the destination, and we have majorly one path, one path, two path, three path, four path. So brute force will try all the possibilities. Suppose generally what we will do, we will choose this one, only this one, or this one, or this one, or this one. But brute force technique will try all the possibilities to find the best solution. Next one is transformation. What it does, convert the problem into the another problem. Suppose we have converting the problem into some other form which we know how to solve this problem. So we will transform the problem into some other problem. Next is dynamic. Dynamic, what it will do? Basically, dynamic break the problem into sub problems and solve the sub problems recursively, but will not calculate the sub problem again and again. Suppose example of factorial 6. It further call factorial 5, factorial 5, factorial 4. Again it will call factorial 4, factorial 3. Now see, factorial 3, factorial 2. Now, in the divide and conquer technique, we will compute all the possibilities, right? But in the dynamic programming, we will not calculate this factorial 4 and 4 again and again. First time we will calculate this time and we will store in the table, in the data structure, F4 value. Next time when we are using, when we are calling F4, we use this value from this table. This is the divide and conquer for dynamic programming. Next, greedy. Next, greedy. Greedy, what it does, it is always greedy. When we divide the problem into sub problems, what it does, it is always greedy, like repeatedly do what is best now. Suppose we are dividing the problem into 4 parts. It is greedy. It will check what is best for now from all these possibilities. Suppose dividing the problem into 4 sub problems and we are getting the cost. It is 4 here. It is 3. This is the cost. Earned cost 2, 6. So for this particular problem, what is best now? It is 6. So it will continue with this path. Again this. So it will always check for the best possibility for the current scenario. Now, next is iterative improvement. What it does? Repeatedly improve current solution. What it is meaning? When we recursively call the sub problem, what I am saying, up step by step to solve a particular problem, and what we are doing, we are dividing the problem into sub problems. So when we divide the sub problem into sub problems, suppose, so we are repeatedly improving the sub problem here to get the best solution. This is called iterative improvement. What is randomization? It is nothing but using random numbers. That means we are not using any technique, either divide and conquer, dynamic, brute force, greedy, transformation. It is doing nothing. Okay? It is randomly doing some solutions. That is last technique, randomization. Now, the first technique, divide and conquer. As the name itself says, divide and conquer. Now, that means we are dividing the problem into n number of parts. Suppose n is 2, so do 2 parts. Next, what we will do, we'll conquer the subparts, sub-problems, like problem Tn. We are dividing into 2 parts, n by 2, n by 2. Now, suppose this is a small problem. Next, we will combine. What we are doing? We are dividing here. We are conquer, solving the subproblems. Suppose we are getting the small subproblem. What is the next part? We are combining. As the name itself says, divide. Divide the problem into a number of subproblems. Conquer. That means this step. We are divided the problem. Next, we will solve the problem. Right. Next, combine. This is this part. Thus, combine the subproblem solution to get the solution to the original problem. Now, divide and conquer. It is a general method for using recursively. What we are doing, basically, we are calling a recursive function call. When we divide the problem into sub-problems, so we are repeatedly dividing, suppose n times. Suppose we are dividing into n by 2 times. So what we are doing, we are recursively calling the function call again and again. The function call will be same, but the value will different. Like factorial of 6 will call factorial of 5 will call factorial of 4. It will call 3, 2, 1, and we will stop here. Recursively, we are calling. It solves the problem by dividing the data. Data means the problem into subparts, subproblems. Finding the solution for each of the part. Like suppose here is the small problem. We came here. Now, F1 is the small problem. We know the value of F1 equals to 1. We'll give this value to this. What does this mean? F2 is nothing but 2 into F1. Clear? Hai? Next, F3. 3 into F2. F2 की वैल्यू क्या है हमारे पास यहाँ पे 2. F3 is 3 into 2. Now this value goes to F4 and so on. So we are recursively calling this. Now, finally, what we are doing, constructing the final answer from the subproblem, some solutions, like what we are doing, this. We are solving F1, F2, F3, F4, F5 and F6. F6 is the main problem. So we get the solution of X6 by using the solution of F1, F2, F3, F4, F5 and so on. Now, based on dividing problem into subproblems, approach is what? Problem should be of same type. That means when we divide the problem into some number of subproblems, like I have divided F6, F5 or F4. So what it is meaning? It is factorial of 5. The problem was factorial of 6. It further divided into factorial of 5. That means the problem is same, factorial only, but the value will change. This is the meaning. Sub problem must be of same type. Okay. Sub problems do not need to be overlap. Overlapping means what I have said in the Fibonacci part. Fibonacci is of 6 equals to Fibonacci of 5, Fibonacci of 4. Now further, Fibonacci of 4, Fibonacci of 3. It is overlapping, F4 again and again calling. This should not be the case. Now, solve each subproblem recursively. Right? हमने recursive को call कर रहे हैं. फिर finally we will combine all the small problem solutions to get the final problem solution. Usually 2 or more recursive calls are there. Generally 2 या 2 से ज़्यादा. Generally we will divide the problem into 3 parts. This 4 part. But generally we stop at 3 only. Now we will analyze the divide and conquer algorithm. Suppose what it meaning, see the problem n, we are dividing into 2 parts, n by 2, n by 2. Suppose, and this is a small problem, n by 2. Next, we will combine this part. So here this is the divide time. Clear? This is the combine time. If it is a constant, we will discuss this later. But for now, it is a divide time dn. It is a combined time cn. This is the main problem tm, and we will further divide into two parts, tn by 2 plus tn by 2. Now analyze the time complexity. See, we will stop when we get the small problem solution, and we are analyzing or supposing that we get the small problem here only. That means it is constant c when n by 2 की power k. What is this k? Recursively we are dividing. ठीक है, same dividing, and we will stop where? When we reach the small problem. Small problem is when we get the small input size n equals to generally 1. See, so it is, suppose we are n की power 2k. We are stopping here. It is a small problem. We will equate to the 1. That means when we have a small problem, constant or a 1 or a 2 or a 3, the small constants only. So we'll say it as a constant only. Next part, when we have a large input numbers and value it is greater than 2, 3 or some 10,000, 10 lakhs or more than that. That means we are dividing the problem. That is the divide time here. Combined time C, that is the divide C combined time, or the problem is n by b of same size. So 2a t n by b, b is the size of each subproblem, and a is the number of subproblems. See, now see, a, the number of subproblems, we break the problem into how many? N by 2 subproblems. Here a value is 2. Now size is what? 2. N by b, the size of the subproblem in terms of n. हम हर प्रॉब्लम जिसमें डिवाइड कर रहे हैं उसका साइज क्या जा रहा है, राइट? dn, this is the divide time. dn is the time to divide the problem of size into subproblems. C, this is the combined time. Is the time to combine the problem into to get the answer of problem size n. Here we will get solution of this problem. Now see some examples. Examples of divide and conquer are binary search. How? See, in the binary search we have an input array of sorted input array, right? Now we will divide the problem into two parts and we recursively check the value of element to be searched. Suppose in the binary search we have to search x equals to 40 and we have an array of 20, 10, 30, 45, 40, 50, 60. What was the condition? Array should be sorted. So I have taken the sorted array. Now element to be searched is x40. We will divide the array into two parts. We will go to the mid part. Suppose this is the mid. We will check the value of 40 with 30. It is greater or smaller. If it is greater, the value to be searched is greater, then we have to move towards the right part. We will not go to the left part. So what we are doing? We are dividing the problem into two parts. Dividing again, suppose here, dividing this side. So this is the example of first divide and conquer. Next is heap construction. Heap construction, Tower of Hanoi, exponential, there's Fibonacci series. As I've already discussed, like Fibonacci of 6 is what? Fibonacci of 5, Fibonacci of 4, recursively, Fibonacci of 3, Fibonacci of 2, F5, Fibonacci of 4, Fibonacci of 3. Now, quick short, we will discuss next. Quick short, it will divide the array on the basis of pivot element. In the given array, we have to sort the array using the quick sort. So we will take a pivot element, and after first partition, we will divide the array into two subparts basis on the pivot. Pivot will reach to its exact place after the first partition. We will discuss merge sort. In the merge sort, we will take two sorted subarrays and we will combine them. It is an outplace algorithm. We will combine them. Like it is a sorted array, it is a sorted array. We will take the first element, combine and place in the final array. Multiplying large integers, matrix multiplication versus Stresson's matrix multiplication is an example of divide and conquer, closest pair in the plane. Now see the quick sort. Quick sort, what it says. Again, it is using divide and conquer strategy, right? Dividing the array into two parts, dividing the array into two parts on the basis of pivot element. Pivot will use the partitioning algorithm. We will see next. What it will do is, suppose partitioning the array A, P, R. P is the starting index, R is the last index, into two possible non-empty subarrays of this size. Each element is this. Now, each element, that means suppose in the given array I have taken a pivot element this R, last element. So after the first partitioning algorithm, array will reach to its last place. Suppose it is the some number in the 4, 6, 2, it is 5 or it is 7 or it is 1. Take. And now this is the pivot element 5. After the first iteration, what it will do? It will place somewhere here in the array. Now all the left elements should be smaller than this array, this particular number. What it meaning? 4, 2, 1. In the next right side, 6 element. So after the first partition, 5 is reached to its exact position and divide that into two parts. First part is this, next part is this. Now we further recursively call the quick sort on this and quick sort on this.